Hello and welcome to my channel. This video is dedicated to my math students, and this is Enjoying Mathematics with Mr. Austin. Okay, today we are looking at trigonometric ratios. We are looking at 3 of the 6 trigonometric ratios used for solving the angles and sides of a right triangle. Let's look at a right triangle, for instance. Let's label the angles as A, B, and C. And then the sides as A, B, and C. And we have the angle 90 at C. Now this is a right triangle because it contains the right angle, or you can refer to it as a right angled triangle. Now the sides and the angles of this right triangle can be solved using the trigonometric ratios. We have 3, like I said, we are going to look at 3. We have sine, abbreviated as SIN. We have cosine, and cosine is abbreviated as cos. And then we have a tangent, abbreviated as tan. Of course, the other 3 ratios, trigonometric ratios, are actually the reciprocals of these 3 which we are looking at. Now, what is the relationship of these ratios in a right triangle? Let's look at the triangle once more. Now, this triangle has 3 sides with 3 angles inside, one of which is equal to 90 degrees. This angle, right angle here, is equal to 90 degrees. And the other 2 put together gives you another 90 degrees. Now, what are the names given to these sides? The side facing the angle 90, which is of course the longest side of the right triangle, is known as the hypotenuse. Hypotenuse. I will abbreviate it as HYP. Then the other 2 sides are known as the adjacent sides. So I will use ADJ. Now, these adjacent sides could also mean opposite depending on the angle you are looking at. If I'm considering angle B, which is here, with theta there, this side facing angle B is known as opposite to angle B, while this side that connects this end to the angle 90 is known as the adjacent of angle B. So if I'm looking at B now, this becomes my opposite, and then this is my adjacent. If I'm looking at angle A, this is better, then A becomes opposite. Now let's look at the relationship of the sides and the angles we have in the right triangle. For sine, the ratio is expressed as opposite over hypotenuse. That's for sine. For cosine, we have adjacent over hypotenuse. Then for tan, we have opposite over adjacent. So if we are to use angle B, for instance, in solving, what we are going to have is this. Using angle B, we will have opposite over adjacent. Opposite over adjacent using angle B. The opposite and then the adjacent. And which of the three ratios has the opposite over adjacent? Something you must remember is SOHCAHTOA. SOHCAHTOA. The S in the SO is for sine, the C in the CA is for cosine, and the T in the TOA is for tangent. So when you remember your SOHCAHTOA, you remember SO, the O here is opposite over hypotenuse. In CA, C is for cosine, which gives you adjacent over hypotenuse. And then in TOA, the T is tan, which gives you opposite over adjacent. Now using angle B, we have opposite over adjacent. That gives you what? Opposite over adjacent. That is what? Tan. So we say tan theta is equal to, what's the opposite to B? Is small letter b. So we say B over adjacent, which is what? A. Let's look at the other side. We have hypotenuse here and we have adjacent. So adjacent over hypotenuse, we have it in CA, which is cosine. Adjacent over hypotenuse, so cos. So we say cos theta is equal to adjacent over hypotenuse. What's the adjacent here? A. So we have adjacent, and what's the hypotenuse? C. Now let's also consider the third one, which is a sine. So we have opposite over hypotenuse. Opposite over hypotenuse. So opposite over hypotenuse, which is sine. So where is the opposite here? B. And then the hypotenuse is what? Is C. So for sine, we have opposite, which is B over hypotenuse, which is C. So using only angle B, we are able to express the three trigonometric ratios, starting with tan there, which is opposite over adjacent. So opposite here is B, adjacent is A. So we have B over A. The next one we have is cos theta. We said it's A over C. How do they arrive at A over C? Cos is adjacent over hypotenuse. And the adjacent here is A, while the hypotenuse is what? C. That's why we have A over C. Then sine theta, we said B over C. How do they arrive at that? Sine is opposite over hypotenuse. And the opposite of this angle B is small letter b. Hypotenuse is what? C. So opposite over hypotenuse, B over C. That's why I have B over C here. Now, this is the foundation of using these three trigonometric ratios in expressing the sides and the angles of a right triangle. Watch out for my next video on working examples using the trigonometric ratios. Thanks for watching.